We have discussed about the differences between classical machine learning and deep learning, and also about some of the characteristics of deep learning and its applications. So let's take now a look at the walkthrough associated with the exercise in this section. You were supposed to train your very first simple neural network model, and once you have created the pipeline in the designer, first thing you needed to do was to set the default compute target for the pipeline. Next, you have registered the dataset named NYC taxi sample data, the dataset that will be used to train your machine learning model, and you have specified the URL that Azure Machine Learning used to download the dataset and then register it in the dataset section. So once that was in place in your pipeline, you were able to locate the NYC taxi sample dataset in the My Datasets subsection of the dataset section in the task panel. The next step performed here was to split the data, and you have used the split data task specifying a splitting mode of split rows and using a fraction of 0.7 for the split. This actually means that 70% of your rows will be used as training data, and the remaining 30% will be used as testing data. So once that was in place, the next important step was to actually select the algorithm used to train the model. And because we are aiming here to train the first neural net, we have specified the neural network regression algorithm. And the important settings that you have performed on the algorithm were training using a single parameter, specifying a fully connected hidden layer, and also some of the defaults were used here, like the number of hidden nodes, which is 100. So think about this. This is a neural net that has 100 nodes in the hidden layer, and that hidden layer is fully connected with the inputs and the outputs. You have also specified here the learning rate of the neural network, which basically is one of the core hyperparameters in every single neural net, and it actually controls the speed at which the internal weights of the neural network are updated as part of the learning process. And finally, you specify that you want to use a number of 100 learning iterations. Next, you have used the train model task to do the actual training of your machine learning model. You have connected the output of the algorithm selection task and also the first output of the split data task, which is, as we already mentioned, the training data set. And you have also specified with the trained model that the column, the target column, the label column is total amount. Next, you have used the score model task to use the trained machine learning model for scoring against the test data set. And hence you have connected the second output of the split data task, which is your test data set, to the second input of the score model task. And finally, you have used evaluate model to evaluate the performance of your model. Once all was in place, you have run the pipeline. And once the pipeline successfully run, you were able to view some of the results of the pipeline. First, on the score model task, right-clicking and selecting the visualizations for the score model result, you could actually see the predictions made by your trained model. As you can see here in the last column, the scored labels column is basically containing the predictions that were made by your machine learning algorithm, and you can also compare them with the actual values which are contained in the total amount. Now, for a more detailed comparison, you can go to Evaluate Model, where right-clicking and selecting Visualize Evaluation Results opens the Evaluate Model Result Visualization interface, where you can actually see some of the core metrics of your machine learning model. So you can see here that you have a root mean squared error of 3.84, and you have a coefficient of determination between the actual amounts and the predicted amounts of 0.86. Remember that the closer it gets to 1, the better the performance of your model is.